automobile body consists of large amount of stamped sheet metals welded together by resistance spot welding. Average automobile has 4,500 to 6,500 welds to hold the body together. Welding process consumes large amount of energy. What is expulsion? If excessive heat is applied or applied too quickly to a weld, the metal in the veined surfaces will be melted. The molten metal is expelled to the air under high pressure. When molten metal meets the air, a burst of bright light is emitted. It is called expulsion. A modern day assembly line, 50% to 100% of all welds are expulsion welds. Expulsion welds is not as strong as non-expulsion weld. Also consumes 3 to 4 times more energy than a non-expulsion weld. By eliminating all expulsion welds on the automobile assembly line, you can easily save 65% or more on energy usage and at the same time greatly improve the weld quality. Fact or fiction? No spark, no weld. A stuck weld or missing weld does not produce expulsion. A good weld also does not produce expulsion. Since conventional weld controller cannot detect the existence of a weld, the weld schedule is set intentionally to produce expulsion. In this case, expulsion is used as a weld indicator. After a weld is completely formed, 2 to 3 times more energy is added just to have expulsion to provide us with a visual feedback. This is a Camry hybrid plant in Melbourne, Australia. This is a minivan plant in the U.S.
Structure of the van. It's made up of the radiator support, 2 side rails, and clips on the front of those side rails for the bumper structure. Then they put this front structure onto the automated production line. Meanwhile, robots weld what's known as the ladder assembly. It's the backbone that supports the floor and sides of the van. It contains, among other things, the pockets that will hold the seats.
This is a manual assembly line in Asia. Severe expulsion can cause porosity and void, undersized weld, expulsion burns through weld, cracks and holes, excessive indentation, non-round weld. The cross-section of a good non-expulsion weld. Using expulsion-free algorithm to weld a non-expulsion weld. Number 1, produce a good non-expulsion weld every single time. Number 2, once programmed, it produces similar diameter welds regardless of the weld cap condition. Number 3, it uses minimal amount of energy to produce the largest possible weld nugget. Number 4, it detects existence of a weld during the weld. Number 5, it also differentiates a good weld from a marginal weld. If you use conventional well controller to well, number one, produce expulsion well most of the time. Number two, need current stepper or tip dresser to compensate the well cap changes. Number three, it uses 3 to 4 times the energy than expulsion free algorithm to produce a substandard well. Number four, it detects the existence of a well by expulsion. Number five, it cannot differentiate a good well from a missing or stuck well. How my expulsion free algorithm eliminates the expulsion well and inspect the well in real time. Number one, use the tip voltage to provide the negative feedback signal to close the feedback loop. Number two, digitize the voltage signal of several test wells to establish a model of the well. Number three, use the feedback voltage compared with the stored model to terminate the well just before the expulsion. An experiment was performed with the expulsion-free algorithm to verify the repeatability of the nugget size. Among them, 60 wells are real wells and the 5800 wells are simulated well with 9.5 kiloampere and 170 milliseconds. The average diameter is 5.78 millimeter with a 6.5 millimeter B cap. Pictures on the last slide show the 3 coupons welded with this intelligent welder. Coupon number 1 has 3 welds with diameter of 5.85 millimeter, 5.83, and 5.84. Coupon number 10, 5.90, 5.88, and a 5.62. Coupon number 19, which is the last coupon, 5.75, 5.79, 5.52. There are 1,300 welds between coupon number 1 and coupon number 10. There are 4,900 welds between coupon number 1 and coupon number 19. The largest deviation from the mean is minus 4.42% to plus 2.15%. On a 2 by 6 inches coupon, I can have 10 welds placed as fast as possible, and after the weld, the coupon is barely warm when I hold it. This experiment highlights the high energy efficiency of the weld controller. It did not waste any heat to heat up the coupon after the weld is finished. This expulsion-free well controller is also a real-time monitor. Since we don't well with expulsion anymore, so a white LED lamp turns on to indicate a well has been started. A green LED lamp turns on after the well to indicate a good well has been produced. A red LED turns on and stays on after a well to indicate that an open loop well is produced. How much energy can we save if everybody uses this expulsion-free welder? With some of the experimentation done several years ago and some of my experimentation, the conclusion is the energy saving per car is approximately estimated at 17.43 kilowatt hour. Continue on from the previous slide. If the energy cost is 5 cents per kilowatt hour, the energy saving using intelligent welder such as this can save about 87 cents per car. In 2009, there are 51,971,328 cars made in the whole world. Total energy saving if everybody uses this way to weld is 905 million kilowatt hour. Each kilowatt hour produces 0.524 pounds of carbon dioxide. This converted to 474 million pounds of less carbon dioxide released to the air. If you're interested to see a demonstration or wanted more information, please contact us, Calvin Shi and John Pippin Jr. Thank you.